Hello, everybody. I hope you're doing well. Welcome to Chapter 6. As you might already know, I uploaded an article here that you see on the left side of the screen on Blackboard last night. Um, the reason why I decided to upload an article for this chapter was that you guys practice a more of an independent type of a studying. You need to practice how to read book chapters in research methods or how to read scientific articles. For this first time that I gave you an article, I'm going to walk you through the important sections of this article, and I'm going to explain how for the future you need to take notes and how you need to simplify the information that you read. Well, first of all, or the first step is that you read the article fully. And by reading the article fully, I do not mean to read over every single section or to memorize anything. By reading first, I'm more talking about skimming through the concepts and familiarizing yourself with the terminology that is discussed here. So I will go through the article on the left side, and I'm showing you a Word document on the right side. There are some blanks in the Word document here, and as I talk through the article, I will fill out the spaces. Before I start explaining things, I want to give you a heads up that I will not explain every little detail in this chapter. There are a lot of good examples in this article. There are a lot of good explanations. All of them are very straightforward. The sections that I highlighted in green are all tangible examples that help explain the material even better. So I will not waste the time of this video to go over the details. That is for you to read. Some sections I will just skim through, some sections I will not explain the definitions and meanings, which means that it's your responsibility to read those sections and really understand those. Okay, so this chapter is about causation and experimental design. On this Word document here, you see that I listed the learning objectives of this chapter. The learning objectives include understanding the meaning of causation and the criteria for causality and what each criterion means. And for you to understand the logic behind the experimental designs, including the essential components of experimental designs and quasi-experiments. And then you need to learn about the factors that can threaten the internal or causal validity of our experiment, which we will discuss a little bit while I'm explaining. You need to understand the meaning of each threat, and then you're going to learn about the process analysis. And then we have a generalizability or external validity section. And then lastly, we talk about deception and debriefing. Most of the concepts here are to some degree touched on in the previous sections or previous chapters of this course. But in this chapter, we are going to really dig deep in each concept. Some of the concepts here are totally new, but some of them you already know a little bit about. Okay, so we start by introduction to this chapter. On the left side, you see that the article starts by defining causation. And it starts by what identifying causes mean. By causation, we want to figure out why things happen. It's not an easy task to do, but it's the goal of most social science research. So here, causation is the process of figuring out why things happen. And then here we have the definition of a cause, which is an explanation of some characteristics, attitudes, behaviors of groups, individuals, or other entities, or events. So a cause is defined here. And then the article goes through explaining why we want to find out the reason behind things. So, to find a causal effect between two variables is the process of finding that change in one variable leads to change in another variable. I'm going to give a review of independent and dependent variable. Independent variables are our exposures. For example, in the example of smoking cigarettes and lung cancer, smoking cigarette is the exposure or the independent variable. As the degree of smoking cigarettes change, the onset of lung cancer in individuals will change as a result. So the onset of lung cancer would be our outcome, or it would be our dependent variable. So whenever you want to be able to identify what dependent variables are, you need to think about what the outcome is. For example, if I want to explore the relationship between hours of studying in the library and performance in exams, performance in exams is the outcome. So performance on exams is going to be the dependent variable, and hours of studying in the library is our independent variable. So aside from finding relationships or correlations, we want to see whether we can identify whether our independent variables can quote unquote cause our dependent variables. So we have a tool that is experimental designs. Experimental designs are the best and most powerful way to evaluate causal hypotheses. Experimental designs are aimed at really putting things into experiments by researchers. For example, going back to the example of studying hours of studying in the library and performance on exams, we can go ahead and observe students or ask them how many hours they study in the library and then look at their test scores or their performance on exams. That will be an observation. It's not going to be an experiment. If we want to do an experiment, we need to really assign participants to our research study and then ask them to go to the library and study for specific hours, and then give them exams, and then try to find out whether the hours of studying in the library changed anything in their performance in their exams. So there is a difference between observing and collecting data from a phenomenon that is already happening around us and an experiment. An experiment is what we formulate ourselves. It's not naturally occurring. So it's the best and most powerful way to evaluate causal hypotheses, and it allows us to confidently establish the first three criteria for causality. The article discusses all of these criteria, but the first three criteria for causality are association, time order, or non-spuriousness. You have heard of these before. Association was previously discussed in our class as empirical association, as you see here. And then time order was previously discussed in our class as temporal ordering or temporal priority. And then non-spuriousness was discussed. Okay, so the next section of this article is going to give us the criteria that we need to meet in order to be able to draw causal relationships between two variables. So the criteria for causality are listed here in this article. The first three criteria are absolutely required. Without one or more of these three criteria, we cannot conclude causality between two variables. And the last two criteria are not required, but they strengthen our causal relationship. Okay, so let's see what the first, let's fill out this graph. The first criteria is empirical association. The second criteria is time order or temporal ordering. And the third criteria is non-spuriousness. These three criteria are absolutely required. And the last two criteria are mechanism and context. Okay, so let's go through what briefly each means. I'm not going to go through all the details or examples. I'm just going to give you general definitions. So association is the first criteria. Before we can conclude that our independent variable causes our dependent variable, we need to find an association between these two variables. They must change together. It means that when our independent variable goes up or down, our dependent variable should also go up or down at the same time. Time order talks about the requirement that variation in our independent variable should occur first, meaning that it should occur before the variation in our dependent variable. So any changes should first happen to our independent variable and then happen in our dependent variable. Non-spuriousness talks about whether the relationship between our independent and dependent variables are genuine. And then mechanism talks about whether we can explain why there is an association between our two variables. Here in this purple box here, I gave you an example of what mechanism means. And then context talks about whether the relationship that we found or the correlation or association that we found between our independent and dependent variable are specific to when, for whom, and in what conditions that association holds true. Okay, so in the next section of the article, we are going to talk about the essential components of true experiments. These are the three essential components of true experiments here. So I have it in a graph or a diagram. The first essential component of true experiments is that we need to have two comparison groups. So we need to have two comparison groups. The reason why we need two comparison groups is that we need to be able to see whether the relationship holds true for different groups of people or participants. Let me change the font here to black. Okay. And then here and here. Okay. we need to have two comparison groups to be able to establish association. Our two groups, one of them is our experimental group, and the other group is our control or comparison group. Okay. And then the second necessary component of experimental designs is that variation in the independent variable should happen before the assessment of change in the dependent variable. So before we assess any changes in our outcome or in our dependent variable, we need to see changes in our independent variable first. And this is to establish time order. And then the third component is random assignment to the two or more study groups. And we do that to establish non-spuriousness. So imagine that we want to study, back to the example of hours of studying in the library and performance on the exam. If we have only one group, okay, we assign one group of students to go study in the library, and then we give them a test to figure out their performance on the exam as a result of studying in the library. If we do not have a control group who did not spend any hours in the library, we cannot conclude a relationship between hours of studying and performance on the exam. Maybe the group of students that we picked are doing other things. Maybe they are maybe they are attending tutoring sessions. Maybe they are studying more at home because they are in the study. Maybe they are engaging in other practices that help their performance on the exam. So if we do not have a separate group where we do not ask them to study in the library, the conclusion of our study is not going to be a reliable conclusion. So we need to have a random assignment to the two of our study groups. The reason for random assignment, which we will discuss later in this chapter, is that we do not want to be biased. If I go to one of my classes and ask some of my students to spend hours in the library, my decision might be biased because I might select the students that naturally obtain better grades. Okay, so in the next sections of the article, it's discussing in more detail of what a true experiment is. So we can determine, by doing true experiments, we can determine whether there is an association, whether there is an association between the independent and dependent variables. Our experimental group receives treatment or experimental manipulation. In the example of sitting in the library, our experimental group are going to receive a quote-unquote treatment, and the treatment would be going to the library and studying in the library. And then our control group is a comparison group that receives no treatment. All true experiments, which you will read through the article talking about post-test and pre-test, all true experiments include a post-test measurement. Post-test measurement refers to measuring the outcome after the treatment was established. So a measurement of the outcome in both groups, both the control and the experimental group, after the experimental group has received the treatment. And not all, but many true experiments include a pre-test measurement. A pre-test measurement is a measurement of the dependent variable or the outcome before the experimental intervention. Okay, then later in the article, it's talking about randomization. I put a purple box here to explain things further. There's a difference between random sampling and random assignment. Read this box to see what the difference is. So for doing true experiments, it's crucial that two groups be more or less equal at the beginning of the study. So, the approach that we choose to make sure that our groups are equal at the beginning of a study before we establish any treatment is by random assignment or randomization, meaning that we randomly assign participants into one of our study groups. Either it's a control group or it's a treatment group. Random assignment ensures internal validity and not external validity. You will learn more about internal and external validity later in the article. Excuse me. And then here in this section, you read about matching. Matching is not as ideal as a random assignment, but is another approach to assign individuals into groups. It's sometimes used to equate experimental and comparison groups, but it's a poor substitution for randomization. It might involve pairing persons on a basis of similarity of gender, age, year in school, or some other characteristics. It means that, for example, if we have half of our experimental group as women, we make sure that in our control group, half of our participants are women as well. Okay, so after learning about true experiments, there are 5 reasons why true experiments might not be feasible to do. Those reasons are here. I underlined them here in the article. First of all, the experiment may be too costly. The second reason is that it might take too long. The third reason is that it might not be ethical to randomly assign subjects to the different conditions. For example, it might not be ethical to ask people to smoke cigarettes to see whether they develop lung cancer or not. It's not ethical to do. Maybe too late to do. Too long to carry out. Might not be ethical to randomly assign, and it might be too late to do. Okay, there are actually 4 reasons, not 5. Okay. Then when a true experiment is not possible to do, we do quasi-experiments. Quasi-experiments is where we are not able to randomly assign people into two groups. So what happens is that we only have an experiment group. For example, let's say that in the example of studying in a library, I only have a group of students who I ask them to study in the library, but I don't have any control groups, and it's too late for me to restart the experiment. So I go ahead and ask other students to see whether they have ever studied in the library. And I select the students who have never studied in the library, who have never received the treatment per se. And then I assign that group as my control group. So although the control group is being assigned later, we still need to make sure that our control group meets the specific criteria to be comparable to the experiment group. There are two major quasi-experimental designs. The first is non-equivalent control group design, and the second type is before and after designs. The non-equivalent control group is exactly the example that I just gave you. So in non-equivalent control group designs, we have experimental and comparison groups that are designed before the treatment occurs, but are not created by random assignment. So in the example of studying a library, I go and handpick students. I literally ask them whether they have ever studied in the library. It's not a random selection. I literally ask them whether they have ever studied in the library. And then in the before and after design, we only have a group, but we have a pre-test and a post-test on our experimental group. In this case, the subjects in our experimental group that are going to be exposed to the treatment serve at an earlier time as their own control group. So at the pre-test, they have not received a treatment, so they are technically a control group. Then they receive a treatment and then become an experimental group. So their situation or the variables that we are going to measure before the treatment is a control, and then after the treatment is established, the measurements at the post-test are going to be our experimental group. Okay. In this purple box, I gave a little review of measurement validity, and here I explained how measurement validity is different from internal and external validity. The parentheses here are definitions of internal and external validity. So the next section in the article discusses the threats to validity in experiments. The threats, I'm just going to complete this diagram here. So the first threat is non-comparable groups. This is the section where I'm not going to go through in detail. There are many good examples in the article that explains all of these threats very clearly. Non-comparable groups, either there is a selection bias, there is mortality, there is instrument decay, and then the second threat is endogenous change. In the endogenous change category, let's see what we have in the article. We have the first one is testing. We have maturation. We have regression. And then the third threat is history or external events. The next one is here, contamination. And then the last one is treatment misidentification. Okay, you need to read all of these paragraphs to be able to learn what each are. The purple box here is the comparison between a double blind and a single blind procedure. In the treatment misidentification, we have other categories as well. We have expectancies of experiment staff. It's larger. We have placebo effect, and we have Hawthorne effect. Okay. And then here talks about the process analyses, where there is a which is a periodic measurement technique to make sure that the treatment is being delivered as planned. So process analysis here is a technique. And then the next section is talking about generalizability. In the generalizability section, we have two concepts or two different aspects of generalizability. Either we have a sample generalizability, which refers to being able to apply findings to some clearly defined larger population. So we basically want to see whether our sample is representative of our larger population. So this is the definition of sample generalizability. And then we have cross-population generalizability. Cross-population generalizability is the ability of our study or our findings to generalize our conclusions to other populations. If we are studying, establishing an experiment in the United States, does it also apply to the residents of Europe or Asia? Could we apply our conclusions to other countries? So this graph is basically different types of generalizability. Again, it's sample generalizability and cross population. Okay. Then after that, we have the deception section. It talks about why we use deception. There are some conditions where we absolutes right here. This diagram here is basically the summary of this paragraph. So sometimes there are some conditions that need to be met in order to be able to deceive our participants. There are 4 conditions listed here under the category of conditional deception. And then sometimes we should absolutely not deceive our participants. And we should not deceive our participants when the experiment is about significant aspects of the research that would affect the participants' willingness to participate. For example, we should not ever hide or lie about the physical risks of the treatment or the study or any discomfort associated with the study, unpleasant emotional experiences that participants might experience. So we should not deceive participants about those. And then at the end of our experiment, if we deceive our participants in any way, we need to debrief the participants, meaning that we need to explain the true nature of the experiment to the subject after the experiment is done. Okay, so the paragraph of the conclusion wraps everything up very nicely. There are some key terms here. You don't really need to go through this list. It's not necessary. And the highlights in the article are very helpful. It wraps up everything and it brings everything together. So by looking at this Word document, go through the list for yourself. So we started by defining what causation means. And then we continued on with what experimental designs are. And then we learned about the factors that can threaten the internal validity of our experiment. Then we talked about the generalizability of our experiments, and then we talked about deception and debriefing. Okay, so go through all of these diagrams and graphs. The explanations that I gave here are absolutely very general and kind of give you a study guide here. You really need to read the article word by word, and you need to study the article and really learn what each of these concepts are. So on Wednesday, which is tomorrow, I will give you a short assignment. And by saying short, I mean that there's going to be multiple choice questions and true and false questions. You will not be asked to write things down, but it's kind of a way for me to realize whether you learned things or not. So definitely do not rely on the fact that you have access to your notes. Really study and understand these material. And if you have difficulty learning or understanding anything, we will have Zoom or Skype appointments on Fridays. If there is anything pressing about the assignment that I will post tomorrow, or if there is a misunderstanding about questions, feel free to email me. Okay, so I hope you enjoyed this. I will post this, and please let me know if you have any questions. Thank you, and have a good rest of the day.